Hello friends, Namaste, hope all of you are well. This is our third lecture of redox reaction, lecture number 3. As we have already discussed 2 lectures of redox reaction. So you can see in this lecture, especially we will discuss about the types of redox reaction. In the lecture number 1 and lecture number 2. Lecture number 1 was just an introduction of redox reaction, and lecture number 2 was how to balance the redox reaction by the oxidation number n. Means there are 2 methods, oxidation number method and second was half cell method. And in this, especially about this video if I talk, then in this video we will discuss about the types of redox reaction. Now you can ask me, sir, in the redox reaction also types. I hope that all of you have remembered the 10 standard chemical reaction. In that your teacher may have taught you the types of chemical reaction. First one was the composition or combinations reaction. Second one was decomposition. Third one was displacement and fourth one was double displacement. Similarly here also in the redox reaction we will start with the same category, but here we have to choose about the oxidation and reduction. That was just by combining. It will be similarly only, the reaction will be also known as the combination reaction only, but in this combination you have to show that it is a redox combination reaction. Just suppose if I talk about combination reaction, okay, first reaction I am talking about the combination reaction. What is combination reaction? Can you tell me? Can anyone tell me what is combination reactions? In combination reaction you may have heard about that when 2 or more than 2 reactants combine to form a single product is called combination reaction, right? So just suppose carbon plus oxygen gives carbon dioxide, right? Here the carbon is existing in 0 oxidation state, oxygen also 0. Here carbon plus 4 and oxygen minus 2, that's minus 4. So 0 to plus 4 oxidation and 0 to minus 2, that's reduction, right? So can we say this reaction is a redox reaction or not? See, remember dear students, when we talk about combination reaction, so similarly there are 2 reactants, they both have combined and form a single product. In this single product formation, you have to not notice that which element is there or what is there. You must know the oxidation number or oxidation states of the elements as they are forming the compound. So can you say, because both the phenomenon is occurring, oxidation also, reduction also, and one more thing, it is a combination reaction. So can we say this reaction is a combination redox reaction? Yes or no? Just tell me about that. Can we say it as a combination redox reaction or not? I hope that all of you will not disagree with the combination redox reaction, because here if I talk about anything, okay, anything means anything, just remember in the redox reaction, the reaction will be what? Just A plus B, the 2 reactants will be there and they will form a single product, A plus B is equal to C. In this reaction you have to just show that the reactants are being oxidation and reduction. In this single product you have to show this both the phenomenon that either A or B, both A and B must be in the elemental form such a reaction to be a redox reaction. All the combustion reactions which make use of elemental dioxygen as well as other reactions involving elements other than the dioxygen are called redox reaction. So here you can see one example. If you know very well, carbon and oxygen, when they both will burn, they both are heated, so they will produce carbon dioxide. Generally exothermic reactions are combinations reaction. Second reaction is, if I talk about magnesium and nitrogen, 3Mg plus N2, 3Mg plus N2 gives, can you tell me what it will give? 3Mg plus magnesium plus nitrogen is this, both element will come in the form of combustion, then they will produce Mg3N2, magnesium nitride. Okay, Mg3N2. Now you can tell me here both the elements are in the form of zero oxidation state. Here, this thing you should remember, that magnesium is here in the +2 oxidation state and magnesium is in the -3 oxidation state. Okay. So here 0 to +2, it will be known as oxidation reaction because the oxidation state has been increased, loss of electrons, and here gaining of electrons and oxidation state has been decreased. So this is reduction. So can we say this reaction as that it is a redox reaction, means combination redox reaction, right? Both examples are already given in your NCERT. Now I will talk about methane plus oxygen. If you will burn methane, CH4 plus 2O2, can you tell me what it will form? It will give you CO2 plus H2O, right? Is it right? Yes or no? Is this reaction balanced? I don't think so it is balanced. I don't think so that this reaction is balanced. Because if we put here 2, then there will be 4 hydrogen and then the reaction will be balanced. Now you have to show that in which oxidation state the elements are there. Here you can see the carbon is in +4, hydrogen -1, oxygen 0, carbon +4, oxygen -2, hydrogen +1, oxygen -2. So you can see everywhere oxygen has got -2 oxidation state. So 0 to -2, it's called reduction. Can we say it as a reduction? Yes or no? Definitely we can say. And -1 to +1, -1 to +1, it's oxidation. So we can say this reaction is a combination redox reaction. So I hope that this thing already you have understand in the 10th standard that what is combination reaction. Here in the combination reaction you just have to show that how it is a combination redox reaction. So here as you have seen in this 3 reaction, it's very easy to say that these reactions are combination redox reaction. Now we are moving towards the second reaction, that is decomposition. Decomposition means what? I hope in the 10th standard already you have heard about the decomposition reaction. Right? The second reaction is decomposition reaction. Decompose. What is the meaning of decompose? Decomposition means that A break down into B and C. Right? This is called decomposition reaction. Means when one reactant breaks into 2 or more than 2 products, that reaction is called decomposition. Decomposition means breaking down. Any reaction you can say breaking down. If I talk about water, H2O. H2O will break in the gaseous form as H2 and half O2. Right? H2 and half O2. So you can see here it is in the +1 oxidation, -2, 0, 0. So here from +1 to 0, it's called reduction, and -2 to 0, oxidation. So here you can say that this is a decomposition redox reaction. When any reaction means it decomposes into 2 or more than 2 products, then you can say that this reaction is redox reaction. Now you will ask me, sir, is it possible to break down without doing anything? No. You have to give heat to break down this reaction. So here decompose, H2O will decompose into H2 plus half O2. And if you want to give single oxygen molecule, then also here it will become 2H2O will break down into H2 and 1O2. You can write like this also. So it's not very difficult as I am saying you. It's very easy here. So you can say here that this is a decomposition reaction. Right? Now I will talk about the another types of decomposition reaction, sodium hydride. Sodium hydride means NaH, 2NaH will break down into sodium and hydrogen, Na and H2, right? So here you can say sodium is existing in 2 plus 1 and hydrogen minus 1. Plus 1 to 0 and minus 1 to 0. They both are in the zero oxidation state. So sodium plus 1 to 0 is reduction and minus 1 to 0 is oxidation. So we can clearly say that this reaction is redox reaction of decomposition. And the third example, which is already given in the NCERT, is potassium chlorate, KClO3. KClO3. Can you tell me that potassium chlorate decomposed into which form? It will decompose into potassium chloride and oxygen. Potassium chloride and oxygen. So you can see this reaction is a balanced reaction. Now here it's not very difficult to find the oxidation number. Minus 2 3 ja minus 6. So it is the minus 2 valency of oxygen here. Potassium plus 1. So plus 5 will be the oxidation state of oxygen. Why? Because minus 2 3 ja minus 6 plus 5 and plus 1 will be 6 and this compound will be balanced. So here the oxidation states of oxygen is minus 2. How much? Minus 2. So write it clearly so you will understand that here oxygen exists into minus 2 oxidation state. Now here potassium plus 1 and chlorine minus 1, oxygen 0. So you can see here plus 1 to plus 1 nothing, plus 5 to minus 1 it's a reduction, plus 5 to minus 1 it will be known as a reduction, and minus 2 to 0 it will be known as oxidation, right? So can we say this decomposition reaction is a redox decomposition reaction? So you can see here decomposition reactions are the opposites of combination reactions. Precisely a decomposition reaction leads to the breakdown of a compound into two or more than two compounds, at least one of which must be in the elemental state. So you can see the examples. It may be carefully be noted that there is no change in the oxidation number of hydrogen. Have you seen? There is no change in the oxidation number of hydrogen in methane under the combination reactions, and that of the potassium in potassium chlorate in the reaction. This may be also noted that here that all the decomposition reactions are not redox reaction. All the decomposition reactions are not redox reaction. So as for example, as I have given you on that day one reaction, that was calcium carbonate, CaCO3 breakdown into CaO and plus CO2. So here calcium plus 2, carbon plus 4 and oxygen minus 2. Here also calcium plus 2, oxygen minus 2, carbon plus 4, oxygen minus 2. So here you can see in the reactant side and the product side, everywhere the oxidation states of all the elements are same. So this is not a redox reaction. So all the decomposition reactions are not redox reaction. This word you should remember in your mind, that all the decomposition reactions are not redox reaction. Now we will talk about displacement reaction. The third reaction, if you want to take a screenshot of this board, then you can take a screenshot. Then we will move towards the displacement reaction. Third type of reaction. Third is displacement reaction. Can you tell me what is displacement reaction? as you have remembered about the displacement reaction, then I am not wrong that when any compound is there and in front of that compound, if any highly electronegative element is in front of that compound, then that compound will decompose and make a compound with that highly electronegative element or highly electropositive. So first of all, you should remember metal reactivity series. Which metal is more reactive? I hope that you have remembered. It was in the class 10 NCERT page number 51, metal and non-metal chapter. In that the highest was of potassium and the lowest was of gold, if you have remembered them. So if any compound is there and in front of that compound any other compound has came which is highly metal reactivity series, means it is more reactive than that compound's metal, then it will displace from that compound and give you a new compound with the highly electropositive element. Means if I talk about, just suppose there are two types of displacement reaction, one is metal one and another one is non-metal. So first of all I am talking about the metal one. Okay, copper sulfate and zinc. Just suppose copper sulfate, CuSO4Lg. So zinc is more reactive than copper. So what it will form? It will form zinc sulfate, ZnSO4 plus C. Means here copper is in plus 2 oxidation state, sulfate minus 2, zinc 0. But here from plus 2 to 0. Now the copper oxidation state in the product side is 0 and zinc oxidation in the product side is plus 2. Right? So here 0 to plus 2 oxidation and plus 2 to 0 reduction. So can we say this reaction is a redox reaction? Which type of reaction? Displacement redox reaction. Why? Because as you can see here, the copper metal which was not highly reactive than zinc. So when the zinc came in front of copper, so copper has to go from this sulfate and zinc will come in the front of sulfate and it will form a compound called zinc sulfate. This is the life reality, my dear students. In any organization, in any company, I have seen that there was so many intelligent students in section A. So many intelligent students. So all these intelligent students were sitting together and they were having a good coordination between them, among them. So now what had happened, in the next year one new boy has came into the section A. So among that who was the highly very much intelligent, everybody was surrounded again that please show me how this answer came, that answer came. But a new student went, suddenly that new student had entered into the class and he had given answers to the teacher. So everybody had understand this is the highly intelligent student in this class, so we should be with him. So that the previous intelligent student has been replaced with the newly intelligent students. Many more examples are there in the life. You will see in your life the many things which you have. Just suppose the two shirts are there in shopping malls and both the shops you have gone into the trial room and both the shirts you have liked that red one also and green one also. Now you will see that which is your favorite color. You have to buy only one shirt. So you will think that this green is looking very fantastic on me. So you will displace this red one and you will buy a green one. So this is called displacement reaction. In anything in our life, as we have seen here, the displacement reaction, everywhere this phenomenon occurs, we choose priority. If they are having highly priority than the previous one, then we choose that highly priority element. Similarly, in the displacement reaction also, as you have seen here, that what had happened in the displacement reaction. Now I am going to take a second example of displacement reaction, that is vanadium pentaoxide plus calcium. Vanadium pentaoxide plus calcium. V2O5 plus Ca. Can you tell me? Calcium is more reactive than vanadium. So it will form calcium oxide, CaO, plus vanadium. Is this reaction balanced? Just check it and say me that this reaction is balanced or not. Yes, this reaction is balanced. Don't forget to put this heat symbol on the reactions. So here you can see that the vanadium exists in the +5 oxidation state, oxygen -2, calcium 0. So now here from +5 to 0, and here from 0 to +2. Right? So 0 to +2 oxidation, and +5 to 0 reduction. So we can say this reaction is a metal displacement redox reaction. So as already I have informed you, there are two types of displacement. One is metal one and another one is of non-metal one. So these are the examples of metals. As you can see, copper sulfate, vanadium pentaoxide, and one more I will give you example. Chromate plus aluminium. Chromate plus aluminium. Cr2O3. Cr2O3. This is chromate plus aluminium. It gives you aluminate Al2O3 plus chromium. Okay, first of all tell me how I will balance this reaction. 2 aluminum is there, 2 aluminum. There's a 2 aluminum, and here 2 chromium is there, so 2 chromium. Now here you can say that -2 plus 3, and here 0. Here +3 -2, here 0. So you can see here +3 to 0, and here 0 to +3. So 0 to +3 oxidation, and +3 to 0 reduction. So we can say that this reaction is metal displacement redox reaction. I hope all of you have understand this metal displacement. Now I will talk about non-metal displacement reaction. Right? So a metal in the compound can be displaced by another metal in the uncombined state. We have already, these all the things have been discussed in the class 10 only. So metal displacement reaction find many applications in metallurgical process in which the pure metal are obtained from their impure compounds, or they are obtained from the impure compound of ores. So you have seen here, in each case the reducing metal is better reducing agent than one that is being reduced, which evidently shows that more capability to lose electron as compared to that is reduced. Now we are talking about the non-metal displacement. The non-metal displacement redox reaction include hydrogen displacement and a rarely occurring reaction involving oxygen as a displacement reaction. No need to worry. Sodium plus water. What will happen? Now we are talking about the non-metal displacement reaction. This was the metal displacement reaction. Now non-metal displacement reaction. Sodium plus water. What will happen? Sodium hydroxide. All of you know very well. Hydrogen gas will be liberated. Sodium plus water gives sodium hydroxide plus right. Is the reaction balanced? Definitely it is balanced. You can see here 4 hydrogen, 2 oxygen, 4 hydrogen, 2 oxygen, and 2 sodium, 2 sodium. Now tell me. Okay, one more question. So we will talk about your sodium or hydrogen. Hydrogen we will talk about because non-metal displacement reaction, right? Okay. One more thing. So sodium is metal and hydrogen is gas, right? So all the alkali metals and some alkaline earth metals like calcium, strontium and barium, which is a very good reactants, will displace hydrogen from cold water. What do? They displace hydrogen from cold water. Okay? Less active metal such as magnesium and iron react with the steam to produce H2 gases. But here you should remember that sodium and water gives you sodium hydroxide and hydrogen. So here you have to choose that how it is a redox reaction. So first of all, you know very well, sodium here exists in the zero oxidation state, hydrogen plus 1, oxygen minus 2. Here, sodium plus 1, oxygen minus 2, hydrogen plus 1, right? Is it okay? Can we write like this? Yes or no? Generally, you write sodium plus and hydroxide minus, but here I am going to show you that here hydrogen is plus 1, sodium is plus 1, and oxygen is minus 2. And here hydrogen exists in the zero oxidation state. So here from sodium 0 to sodium plus, it is oxidation, and hydrogen plus 1 to hydrogen 0. So this is reduction, right? So here you can say that this reaction is non-metal displacement reaction. Same here, calcium plus water, calcium hydroxide plus hydrogen, right? One more reaction I would like to take, that iron plus water. You know, corrosion, corrosion. Iron plus water. Fe plus H2 gives Fe2O3 plus H2. This reaction, can you balance this reaction? Yes or no? Definitely you can balance. What you will do? You will write here 2 iron, because 2 iron here, and 3 oxygen is there, so 3, and here 3 H2, right? Now iron here 0, hydrogen plus 1, oxygen minus 2. Here iron plus 3, oxygen minus 2, hydrogen 0. So from 0 to plus 3, oxidation, and plus 1 to 0, reduction. So can we say that this reaction is a redox reaction? Yes or no? Definitely we can say that this reaction is non-metal displacement reaction, right? And if you want some metals like zinc, magnesium, iron to do reaction with hydrochloric acid, what will happen? Zinc plus hydrochloric acid, magnesium plus hydrochloric acid, iron plus hydrochloric acid. They will just give you the redox reaction. Just see, Zn plus HCl, ZnCl2 plus H2. Here zinc 2 HCl 2, yeah. Zinc 0, hydrogen plus 1, chlorine minus 1. Zinc plus 2 minus 1, and this is 0. So zinc has been oxidation and hydrogen has been reduction. So we can say this reaction is redox reaction. Can we say this reaction is redox reaction? Yes or no? Definitely we can say. Similarly, we can take magnesium and iron also. So these all are used to prepare H2 gases in the laboratory. The reactivity of metal is reflected in the rate of hydrogen gas evolution, which is the slowest for the least active metal like iron and the fastest for most reactive metal like magnesium, and very less active metal which may occur in native states such as silver and gold. Do not react even with the hydrochloric acid also. We have already discussed that the metal, zinc, copper and silver, through the tendency to lose electron, show their reducing activity in the order of zinc is greater than copper is greater than silver. These all are the like metals activity series. They also exist for the halogens also. So no need to worry. The power of these elements as oxidizing agent decreases as they move down towards fluorine to iodine in a group, especially in the group number 17 in the periodic table. This implies that fluorine is so reactive that it can replace chlorine, bromine and iodine ions in the solution. In fact, fluorine is so reactive that it attacks water and displaces the oxygen from water also. Have you ever heard oxygen from water? Water plus F2, H2O plus F2. What it will become, you know? OF2 plus H2. Can you see this reaction? Oxyfluoride, OF2. Is this reaction right? No, this reaction is wrong. Here water will be displaced as hydrogen fluoride, not oxyfluoride. Yeah, hydrogen will displace, na? Because here we are talking about the redox reaction. Right? HF plus O2. So 4HF plus O2. 2O2. No, O2 only. So here you can say that how it is a redox reaction. Hydrogen plus 1, fluorine 0. Plus 1 to minus 1. No, not here. Oxygen minus 2. So here minus 2 to 0 is oxidation, right? And fluorine is highly electronegative. So here fluorine is minus 1. 0 to minus 1. 0 to minus 1. So 0 to minus 1 reduction. So you can say that this reaction is a non-metal displacement reaction. Similarly, if you take any examples of this fluorine, chlorine, bromine, iodine, you can represent these as a very nicely that how these reactions are displacement reaction. Now I am talking about disproportion reaction. Disproportion means disproportion reaction are the special type of redox reaction. In a disproportion reaction, an element in one oxidation state I am talking, okay? One oxidation state is simultaneously oxidized and reduced. One of the reacting substance in a disproportion reaction always contain an element that can exist in at last 3 oxidation state. If I talk about water also, see, I am giving you directly example, no need to make you so much very hard. So just suppose that hydrogen peroxide, how the hydrogen peroxide will dissociate or it will displace. So disproportion reaction. Now we are talking about disproportion reaction. In the 10th standard we have discussed about double displacement. Here it is disproportion reaction. As already I had informed you that hydrogen peroxide gives water plus oxygen. Right? Now what you have seen here, from the hydrogen peroxide, it has removed the water molecule and oxygen molecule. Here hydrogen is in, can you tell me which oxidation state in this compound hydrogen exists in plus 1 or plus 2 and oxygen exists in plus 1 and plus 2? Here, dear student, you should remember that here hydrogen also exists in plus 1 and oxygen in minus 1. Here hydrogen in plus 1, oxygen minus 2 and oxygen 0. So here from minus 1 to minus 2 and minus 1 to 0. Minus 1 to 0 oxidation and minus 1 to minus 2 reduction. So you can say that this reaction is a disproportion redox reaction. Can you say that this reaction is a disproportion redox reaction? Now I am talking about phosphorus P4 plus 3OH plus 3H2O. Okay, P4 plus OH plus H2O. P4 plus OH plus H2O. Can you tell me what it will give? Phosphine PH3. Phosphine plus H3PO2 minus. PH3 plus H3PO2 minus. Right? So here can you tell me that here phosphorus exists in 0. This is minus 1, so minus 2 plus 1. Plus 1 minus 2. First of all, balance the redox reaction. First of all, you have to just balance it. Hydrogen minus 1, phosphorus plus 3. And here that plus 1 minus 2 to the minus 4 plus 1, so plus 3. Here can you tell me phosphorus exists in which oxidation state? Here phosphorus exists in plus 1 into 2 minus 4. Minus 2 is equal to minus 1. So here phosphorus exists in plus 1 oxidation state. Plus 1. Can you ask me here, sir, how plus 1? First of all, balance the redox reaction. What you have to do? 3OH and 3H2O. 3OH 3H2O and 3H3PO2. Here what I have done, this H3PO2, first of all see H3PO2. Here you have to find that hydrogen is 1, so 1 into 3, phosphorus X, oxygen minus 2 into 2 is equal to minus 1. So 3 plus X minus 4 is equal to minus 1. Right? So X minus 1, are you sure, is equal to minus 1. So X is equal to minus 1 plus 1. It will be 0 then. How I have said that it is a plus 1? Because just see in the compound is this H2PO2, not H2PO2. It's not H3PO2, H2PO2. Right? So here 2, 1 into 2. So here also 2. 2 minus 4, it will become minus 2, and minus 2 minus 1 plus 2, that is equal to X is equal to plus 1. So that's why here phosphorus existed plus 1. So from 0 to plus 1, oxidation, 0 to plus 3 also oxidation. Now oxygen and hydrogen plus 1 to minus 1, reduction. Can we say that this reaction is a redox reaction? Definitely we can say. So this type of all the 4 type of this redox reaction you should never forget. Combination redox reaction, after then disproportion, or you can say decomposition redox reaction, then displacement in the 2 types of displacement, metal displacement, non-metal displacement, and the final one is disproportion reaction. So you can take some of the more example like sulfur, chlorine, and you can just check in your NCERT textbook. All these examples are already given. You should remember that how we should manage that these reactions are redox reaction or not, only by understanding the oxidation state. Hope all of you have understand this types of redox reaction. That's all for today. Thank you very much. Hope all of you have understand. If you have not understand, then drop your doubt into the comment box section. And if you have understand, then don't forget to like and subscribe the channel. Share this video with your friends so they can be also benefited. Thank you very much.